This is Mr. Beck Does Your Homework. This is Physics Homework 13, question number 10 and 11. A roller coaster car speeds down a hill past point A and then rolls up a hill past point B as shown in the figure. The car has a speed of 13.5 meters per second at point A. The gravity is 9.81 meters per second. If at point A the track exerts a force on the car that is 2.58 times 10 to the fourth Newton greater than the car's weight, what is the mass of the car? Well, let's see. Free body diagram at that point, at point A, would have gravity pointing down. It would have a normal force from the track pointing up. And since this is going to move in an upward curving circle, I know that my normal force has to be greater than gravity. How much greater? Well, centripetal force greater. So I know that my normal force minus my force of gravity is going to be my centripetal force. Now that I've got that figured out, let me look back at this wording. It says the track exerts a force on the car that is this much greater than the car's weight. So the track exerts a force on the car that is so much greater than the car's weight. That seems to be saying that the normal force minus the gravity is the centripetal force. Well, that must be it. That's how much bigger normal is than gravity. Normal minus gravity. So the track exerts a force that much greater than the car's weight. So normal minus gravity is centripetal. So centripetal equals 2.58 times 10 to the fourth newtons. What is the mass of the car? Well, I have my radius of 10 meters. I have my speed of 13.5 meters per second. And I've got my centripetal force, and I'm looking for my mass. So I can just do Fc equals mv squared over r and solve for mass, and I will get my mass from that one. The next question says, what is the maximum speed the car can have at point B for the gravitational force to hold it on the track? Well, at point B, I have a gravitational force down, and I have a normal force up. The quicker I go up over that path, I know that gravity is greater than the normal force, but the quicker I go, the less the normal force is. You can think about this like the top of Apollo's chariot. As you're going over that hill, it goes just at the right speed where your normal force actually goes to zero. So your normal force would go to zero, and when that happens, the wheels would leave the track. So they don't quite go that quick, but they do make it so that you feel temporarily as if you're weightless. So your normal force goes to zero up at the top. What that means is that my gravity is greater than my normal, so my gravity minus my normal must be my centripetal force. But if my normal force goes to zero, then I get my gravity alone is equal to my centripetal force. If gravity is equal to centripetal, then mg equals mv squared over r, and the mass of the car cancels out. So if I want my speed there at the top of the circle where gravity is equal to the centripetal force, because whatever this force is went to zero, then I can get my speed is the square root of r times g. And that will give me, that's always going to be my magic top of the hill sort of thing that gravity alone pulls it around in a circle.